You must have heard the name Aryabhatta. He was a great mathematician from 16th centuries ago. He has given us a formula and we are going to discuss it today. Of course, he was a mathematician, so he didn't write epics or devotional songs. He wrote formulas. And one of those formulas is like this. Chaturadhikam shatam ashtagunam द्वाषष्टिस्तथा सहस्राणाम् अयुतद्वयस्य विष्कम्भस्य आसन्नौ वृत्तपरिणाहः. One thing, this is mathematics, and then this is in Sanskrit. So, of course, it is difficult to understand. But let's start at the very basic word that we already know. We know the word shatam. Shatam means 100, 100. Chaturadhikam, chatuhu adhikam, 4 more. So 4 more than 100. Then ashtagunam, multiply it by 8. So we get 104 multiplied by 8 is 832. Sthatha, add it to dvashasti sahasranam. Shasti means 60. Dvashasti means 62. Dvashasti sahasranam is 62,000. So 62,000, and that to that add 832 and we get 62,832. What is this? Vritta parinahaha. Vritta means circle. Parinahaha means circumference. So the circumference of the circle is 62,832. Which circle? Whose Vishkamba is Ayut Dvayam. Vishkamba means diameter and Ayut means 10,000. 10 raised to the power of 4. Ayut Dvayam means 10,000 multiplied by 2 is 20,000. So a circle whose diameter is 20,000 has the circumference of 62,832. This is what Aryabhatta has told us in this formula. Now let's start at the very beginning of what we already know about the circle. This is the circle. This is its radius. This is its diameter. And this is the circumference. We already know a formula from our mathematics classes that circumference equals pi multiplied by diameter. If we divide both sides by diameter, then we get pi equals circumference divided by diameter. This relationship, the relationship between circumference and diameter, got the name of pi only in last 3 to 400 years. But this relationship is being studied and explored and revised and refined since last 4,000 years. Civilizations 4,000 years ago have written that the circumference of the circle is 3 times its diameter. Then, 2,300 years from today, came Archimedes. In 3rd century before Christ came Archimedes. And he said that circumference is not actually 3 times its diameter, but it is 3.1408 times. So it's more than 3.1408 times, but less than 3.1429 times. So he gave a range that it's 3.1408 to 3.1429, somewhere in between is the relationship between the circumference and the diameter. 700 years after that came our Aryabhatta, and Aryabhatta gave us this formula. Now, let's try to incorporate the numbers that Aryabhatta has given into the equation that we already know. So we get the number 62,832 equals pi multiplied by 20,000. And so we get the value of pi as 62,832 divided by 20,000. That means pi equals 3.1416. That's pretty close to the number that we know, and that's quite creditable. But I have quite a few questions in this formula. My first question is that why did Aryabhatta choose the diameter of 20,000? If he would have taken the diameter of 10,000, then the calculation would have been very easy. That means we are talking about dividing the denominator by 2, and even the numerator is an even number, 62,832. So he could have written like Chaturadikam Shatam Chaturgunam, not Ashtagunam. So that would have cut down 832 to 416. And then instead of Dvashashti Sahasranam, he could have written Ekatrinshati Sahasranam, 31,000. So that would have given us the number 31,416 divided by 10,000, and the calculation would have been easy. So why did he choose 20,000? Probably the number that he chose was also 10,000, but actually he chose that number as the base to draw his circle. When we draw a circle, we take the distance from its center to the periphery as our base, and then draw the whole circle with that distance. So that is the radius, and the number 10,000 that he may have chosen was the radius, but he had to find the relationship between the diameter and the circumference. And so his diameter became 20,000. My second question is, why did he choose such a large number? He could have taken a circle with a diameter of 2 or 20 or 200 or 2000. In that case, the calculation, the measurement of the circumference would have been easier. But he knew that Archimedes has already told us that the circumference of this circle is somewhere between 3.1408 and 3.1429 if the diameter is 1. So what he wanted to do is to come to a precise number, a specific number. And he knew that if we enlarge the picture, we can get to more precision. And that's why he took such a large diameter. My third question is, why did he make this formula so complicated? Like take 100, add 4 to that, multiply it by 8, add 62,000. Why? That's because let's think from his point of view. We have a piece of paper or maybe a piece of cloth or maybe a pizza or a tortilla or a roti or a dosa, anything which is a perfect circle in our hand. What do we intuitively do? We fold it into 2 and then we again fold it into 2. That's how we fold a circle into 4 folds. So he also may have, I don't know what he did. Nobody knows what he did, but he also may have folded his circle into two and then again into two. And he may have thought that if I measure this arc and multiply it by 4, then I'll get the circumference of this circle. So he cut out the 1/4 piece of that circle. But then he could see that still this 1/4 piece is a huge piece. So maybe he folded it again into two and then decided that whatever I get for this arc, I have to multiply it by 8. So he started huge pieces, and he reached 5,000. He put 5,000 aside, multiplied it by 8 and got 40,000. So, okay, 40,000 is the definite. Now I have to count further. Then he knew that there are no more 5,000 in this. So maybe he counted 2,500. He reached there. He put it aside, multiplied it by 8 and got 20,000. So he added those 20,000 to those 40,000 and got 60,000. Then he could see that there are no 1,000 left in this, not even 500 left in this remaining piece of arc. So he counted to 250. He reached there, multiplied it by 8. He got 2,000 and added those 2,000 to those 60,000. And that's how he got 62,000. Now he knew that I cannot get even 1,000 more. So he started counting piece by piece by piece. And when he reached 100 units, he put them aside and made a mental note that I have to multiply this 100 by 8. Then there was a small piece of arc left. He counted that piece like 1 unit, 2 unit, 3 unit, 4 units, and he's done. And so he added those 4 to 100, and that's how he got Chaturadikam Shatam Ashtagunam. And then Dvashashti Sahasranam he has already counted earlier. That is one of the explanations for making his formula so elaborate. But the two important words in this formula, we need to touch them. The first word is ayut. Ayut means 10,000. 10 to the power of 4. 10 raised to the power of 4. Now, I don't know too many languages, but I know English, Hindi, Marathi, Sanskrit, and Gujarati. And in those languages, we say 10,000, 10,000, 10,000, something like that. Whereas Sanskrit has a specific word for 10,000, ayut. If you know any other language in the world which has a specific word for 1 and 4 zeros, please let me know in the comment box. The second and the most important word in this whole formula is asannav. Asannav means it's coming close, or in mathematical terms, we can say approximately. That word in this formula proves that he was a really great mathematician. It is counterintuitive. As such, we always say that precision is most important in mathematics. And here I'm arguing that because he's saying this is approximately, he's a great mathematician. His number is 3.1416 as the value of pi. Right now, in modern age, science and technology have progressed tremendously. In current time, the value of pi is counted to 62 trillion numbers after the decimal point. So 3 point, and then you keep putting number 1, 2, 3, 4, 5, 6, and you do it for 62 trillion numbers. And that number is something like 3.1415 5, 9, 2, 6, 5, and then the numbers go on and on and on. So what's the difference between Aryabhatta's number, value of pi, and the modern value of pi? The difference is 0.00000734, and then a long line of numbers. That means the difference is close to zero. Difference is negligible. Now, he took a diameter of 20,000, and that's how he could get 4 decimal points. If he wanted more numbers after the decimal points, he could have taken a bigger diameter. Let's say instead of 20,000, he could have taken 200,000, like 2 lakhs, or he could have taken 2 million, like 2 prayut, or he could have taken 20 million, which is 2 koti, or he could have taken 200 millions, like 2 Aryabhatt, anything. And he could have got more numbers after the decimal point. Didn't he know he could have done this? If you and I can think of doing this, definitely he knew how he could have done this. But he thought of stopping at the ideal point. Because though precision is important in mathematics, more important is its utility value. And back then, 1600 years ago, he knew that this value of pi, this relationship between circumference and diameter, is an irrational number. And what's an irrational number? So if we can divide one integer by another integer and get a specific number, that is a rational number. But then there are some numbers whose value you can never get. You can never come to the end by dividing 2 integers. And those numbers are called irrational numbers. So 1600 years ago, Aryabhatta could decide that this is an irrational number and I'll have to stop at an ideal spot. And he stopped at 4 decimal points. This is his greatness, and that's why the word Asan now puts him, proves that he's a great mathematician. So in times to come, when you start teaching your children or your grandchildren or any children in the world, as you teach English, you teach them A for apple. When you teach them mathematics, teach them A for Aryabhatta. And to prove that, give them this formula and its explanation.